Hello students, today's topic is frame buffer. Now before moving on to the frame buffer, first we'll see the working of raster scan display device. Now in the previous video we have seen the components of raster scan display device. So the components are buffer, controller and screen. Now buffer is a component which stores the information. Okay, it's basically a memory location. Controller, the function of controller is to transfer the information from memory to a screen. Okay, and in case of raster scan display device, the screen is divided into small number of discrete cells called pixels. Okay, now here this buffer stores the information of each pixel. So each pixel, whether this pixel, so the information of each pixel is stored in this buffer memory, and according to the information stored in the memory, the controller transfers that information about 50 to 60 times in a second, and because of that this pixel would continuously appear on a screen. Okay, now how this buffer works. So this frame buffer, today's topic is nothing but this, how this buffer works, how this buffer stores the information. So that is our today's topic. Now here you can see this is a buffer, or it is called as frame buffer. Okay, and here you can see the memory location. So each memory location can store the data of 1 bit. It stores the data of 1 bit. It stores 1 bit data. So each memory location stores 1 bit data, either 0 or 1. Okay. Now, so say suppose this is 1 0 1 1 0 0 1 1, like this 0 1 0 0 1 1 0 1 1 1 1 1 0 1 1 0. So like this the entire frame buffer is storing information in the form of bits, 0 or 1. Now we have seen that the electron gun scans the entire area of a screen in a zigzag manner. It scans the entire screen in a zigzag manner, and during its travel of scanning the screen, the electron gun constantly switching on and switching off, and as per the information stored in the frame buffer. So according to the information stored in the frame buffer, this electron gun continuously switching on and switching off. And when the electron gun is switched on, it strikes the phosphor coating, and a bright spot appear on a screen. When the electron gun is not switched on, then it would not hit the phosphor coating, and the bright spot doesn't appear on a screen. Now this we are talking about black and white monitors. We are talking about black and white monitor, where either a black color or a white color is possible on the screen. Now we'll see the working of how this frame buffer works. Now consider this location. Okay. Now whatever the information stored in this memory location, it goes to a register. So since there is only one frame buffer, so one register is there. Okay. Actually the register processes the data bit by bit. So at a time it only stores only 1 bit data. So this information comes to comes to this register. For example, the information is 0. So this information goes to DAC. DAC is digital to analog converter. Okay, because the information which is stored in the memory location is in digital form, whereas the electron gun requires the input in the form of analog voltage. Okay, so to convert the information from digital to analog, we need digital to analog converter. Okay, now this 0 is converted into analog voltage. Obviously the 0 means there is 0 analog voltage, and electron gun doesn't start, and because of that the corresponding position, so it is 1 2 3 4 from this side, so 1 2 3 4, so this will be black, because the electron gun is switched off position, and because of that no electron beam hitting the phosphor coating, and because of that this spot would appear black. Now consider another situation where the register contains a value 1, or this memory location contains 1 bit. So this 1 is converted into corresponding analog voltage. The electron gun would start, and electron beam hits the phosphor coating at this portion, and this portion would appear white. So in this manner the entire screen gets scanned, and as per the information stored in the frame buffer, the same picture would appear on a screen. Now this we are talking about a black and white monitors. Now if you want to increase the number of shades from pure black to pure white, so there may be some gray areas. So to increase the shades between complete black to complete white, we can add the number of frame buffers. So we can add number of frame buffers here. Similarly, so here you can see that there are 3 frame buffers. These are 3 frame buffers. There are 3 frame buffers. So obviously here we require 3 registers. So 1, 2, 3 registers. We require 3 registers. So the 3 values, 3 corresponding values from this side. So this would go to here. This information go to here, and this information go here. So suppose the value stored in this register is say 101. Now this 101 value is converted into DAC, and means digital to analog converter, and it generates some analog voltage, and according to the intensity of the analog voltage, the different shades of this pixel would appear on a screen. either complete black. If it is 0 0 0, that means complete black. 1 1 1 means complete white, and 1 0 1 or 1 0 0 or 0 1 1 would give you different shades of gray. Okay, so this is how this frame buffer works. Now, since this frame buffer stores the information bit by bit, this is also called as bit plane. This is also called as bit plane. Okay, and the number of shades available on the screen is calculated as 2 to the power n, where this is shades. So the different shades which are available on a screen is calculated as 2 to the power n, where n is number of frame buffer. Number of frame buffer. Okay. So hope you understand the working of this frame buffer, how the information is stored in the frame buffer, how it is converted into corresponding analog voltage. Then that analog voltage is used by electron gun to fire an electron beam, and as per the intensity of electron beam, that much intensity of bright spot appear on a screen. Okay. Now the color monitors also works in the same fashion, but in color monitors there are 3 basic frame buffers are given to 3 basic colors. 3 frame buffers are dedicated to 3 basic colors, that is red, blue and green. And as per the information stored in red, blue and green frame buffer, different combinations of color is available on the screen. So this is how a color monitor works. So if you understand the black and white monitors, you can easily understand the working of color monitors. So thank you very much.